Now we're going to move to talking about these symbols, which are what? Square roots, right? That's a square root. You'll probably want to have your calculator out today because I want to show you a few things on it. If you have it on you, if not, it's no big deal. So this is a square root. What's another name for a square root? A synonym. Anybody know what it is? Starts with
Radiant.
radical. Anybody heard that before? No, yeah. Okay.
I'm not a god of grace.
Square roots and radicals are the exact same thing. Square roots and radicals are the exact same thing. So when we talk about square roots, we talk about radicals, we're talking about the same things. They're both this symbol. Okay. So knowing what a square root is, let's talk about numbers that are perfect squares. So when we say perfect square, we're talking about things that have square roots that are whole numbers. Just start shouting them out. What are some examples?
449.
449?
216.
I'll take 16.
32.
36. 9.
You know when your birthday is.
28. 64. Oh,
1, 2, 1.
81.
I had my wrong birthday.
Any others you can think of?
My old neighbor.
Any other perfect squares we can think of?
1, 6, 9.
Okay. And there's a bunch more. I think one small one we forgot was 1. Okay. These are all numbers that are perfect squares. Means if you type them into your calculator, if you type in square root of 4, you get 2. If you type in square root of 49, you get 7. To be a perfect square, you have the square root is a whole number, okay, which means it's 2 numbers that are identical that multiply to get this number. 7 and 7, 4 and 4, 6 and 6, 3 and 3, right? So 2 numbers that are identical to multiply to give you those numbers. So, for example, the answer to this would be 5, right? That's a perfect square. Okay. What we're going to talk about today, though, is what happens how do you simplify when things are not a perfect square? Okay. So, for example, like square root of 24. It's not a perfect square, right? So how do we simplify this without using like the decimal rounding and punch it in on your calculator? Okay. Just like when you simplify a fraction like 2/4, you can simplify it to 1/2. Means the same thing. We can simplify radical 24, square root of 24, and simplify it farther. And there's 2 ways we can do it. I'm going to show you both ways, and you can pick whatever way you like best. Okay. One way is to break square root of 24 down into a perfect square and another number. So what is a perfect square that goes into 24 that's a factor of 24? 4. Is there a bigger one?
8.
8's not a perfect square. 4 is the biggest one, right? Everybody agree with that? So you could break this down into 4 times 6, right? It's still 24. And the reason we broke it down into 4, because that's a perfect square, because one of the rules of a square root, one of the properties of a square root, is that if you have the square root of a multiplication problem, you can make that 2 separate square roots being multiplied. This is just a property of square roots. If you have the square root of a product, or if you have the square root of a multiplication problem, you can break it down into 2 separate square roots. And the square root of 4 is 2. So we simplified square root of 24 into 2 times the square root of 6, or 2 square root of 6, or 2 radical 6. So if you have your calculator out in front of you, if you punch in square root of 24 on your calculator probably says something like 4.8989799486, right? It goes on. And then if you punch in 2 times the square root of 6 on your calculator, you should get the exact same decimal, right? Anybody not get the same decimal? That's one way you can check your answer. You can punch in square root of 24, look at the decimal. You can punch in 2 square root of 6, look at the decimal. They should be exactly the same. You just simplified this. You didn't change it. You just simplified it. Okay? This is one method to doing it, is you break it down into a perfect square and its other factor, and then take care of the square root. The other method to doing it, okay, is kind of like a little trick here. We call it the break it out of jail method. You treat the square root as a jail. Okay? Just bear with me a second. The square root's like a jail cell. Everything, right now 24 is in jail. It's in the square root, right? And how you break out of jail is you factor the number on the inside as far as you can. You factor it as far as you can. And how you break out of jail is you have to have a like partner and only one of you break out of jail. And the other one dies. You have to have a partner to break out of jail. So you have to have, don't go to jail in the first place, right? So if you break out of jail, one of the twos breaks out of jail, the other one gets axed, right? What's left over, okay? What's left over is a 2 and a 3. You just remultiply those together, and it's 2 root 6. Which is the exact same thing as what we had before, 2 root 6, 2 radical 6. Okay? It's just another way to solve the problem. It's just a little trick to use. Okay? It's breaking out of jail. To get out of jail, you have to have a like partner, and only one of you make it out. Okay? Whoever doesn't have a partner stays in the jail. Okay?
That's unfortunate.
Try another one. I'll have you guys try this one first. So you need something out to write with. Simplify radical 12, or square root of 12. Of course, it's not a perfect square. Okay? It's not a perfect square, so break it down as much as you can, using either one of the methods we just did. So the first method we did is we look for a perfect square that's a factor of 12, the biggest perfect square we can. What's a perfect square that's a factor of 12? 4, right? So you could break this down into 4 times 3, which then using the properties of square roots says you can break this down into square root of 4 times square root of 3. Those are the same thing. That's just a rule of square roots. And the square root of 4 is 2 and 3. So the simplified square root is 2 radical 3, 2 times the square root of 3. Okay. The other way you could do it is you could think of it as the jail cell again. Okay. So the 12's in jail. You factor it all the way. Let's say you do 6 and 2. You do 3 and 2. To get out of jail, you have to have a partner that's the same as you. So I'll pair up my partners. There's one set of 2s. One of them gets out. Whatever's left over stays in. And I get the same thing, 2 radical 3. The partners have to be the same. Yeah. Yeah. Same thing either way you want to do it. Whatever way you'd like better, you can do it that way. But it simplifies 2 radical 3. Again, you can check on your calculator. If you do square root of 12 on your calculator, it's about 3.46. If you do 2 radical 3 on your calculator, it should be 3.46 and so.
Whoa.
Try another here. Try square root of 27. Again, not a perfect square, so we're going to have to simplify it. So here, the first method, what's the largest perfect square that's a factor of 27? 9, right? So this can change into 9 times 3, which is the same thing as radical 9 times radical 3, which square root of 9 is 3. That's the answer. The other way of doing it, if you preferred it, square root of 27, I can break this down, for example, into 9 and 3. I can break this down into 3 and 3. So I have one set of 3s. One of those breaks out. I rewrite whatever's left on the inside, which is just a 3, and I get the same thing. Yes? Question?
No.
You go, okay. 3 radical 3. One more of those, and then we'll move on to a new type. Say you have square root of 48. Simplify square root of 48. One other rule that might help you on this one is if multiple things get pulled out of the square root, you just multiply them together. And if multiple things stay in the square root, you just multiply them together. So, one way we can do it, we look for the biggest perfect square that goes into 48. 4 is a perfect square that goes into 48, but there's actually a larger one, which is 16. All right? Let's say, I'll do an example if you used 4 in just a second, but let's say this is the same thing as that. 16 times 3 is 48. And square root of 16 is 4. So the simplified answer is 4 radical 3. Let's say, for example, though, let's say you used 4. So you broke it down into 4, 12. Okay. Well, square root of 4 is 2. But again, there's another perfect square that goes into 12 here. So I could simplify it further, which that simplifies to 4 and 3, which the square root of 4 is 2. And again, if they're both on the outside, they just get multiplied together. And 2 times 2 is 4. So either way you do it with that method, you get 4 radical 3. The other method, if you did it, square root of 48, you factor it. Well, you'll say you use 6 and 8. Doesn't really matter because the factors at the end are going to be the same. You can simplify that to 4 and 2, that to 2 and 2, that to 3 and 2. You pair up any partners you have. I have one set of 2's here. I have another set of 2's here. So that means 2 2's are going to come out, right? 2 times 2, what's left over? Under the radical 3, and I still get 4 radical 3. Doing it that way. Your answer on a calculator, if you do square root of 48 on your calculator, it's about 6.9282. And if you do 4 radical 3 on your calculator, it's the same thing. Now let's say I ask you to multiply 2 different square roots. So if you have square root of 5 times the square root of 10. Okay. Multiplying square roots. One just easy rule to follow with multiplying square roots is you multiply the stuff on the outside of square roots together and you multiply the stuff on the inside of the square roots together. In this case, there's nothing on the outside of the square roots. So square root of 5 times square root of 10 just becomes square root of 50. You just multiply the stuff on the inside of the square root together. But then you can simplify square root of 50 just like we did before. Okay? You can do it either method, but let's say I know 50 breaks down into 25 and 2 because 25 is a perfect square, which is the same thing as square root of 25 times square root of 2, and the square root of 25 is 5. So the square root of 5 times the square root of 10, the simplified answer is 5 radical 2, or 5 times the square root of 2. And you can check on your calculator, is the square root of 50 the same thing as 5 square root of 2? And it should be. Try this then. If you have 2 radical 3 times 3 radical 8. So you multiply the stuff on the outside of the square root together, that stays on the outside. You multiply the stuff on the inside of the square root together, that stays on the inside. And then you simplify the radical as far as you can. So try that yourself for a second here first. I think a lot of us are on the right track here. Again, you multiply stuff on the outside of the square root together. 2 times 3 is 6. You multiply stuff on the inside of the square root together. 3 times 8 is 24. And now you can simplify radical 24, square root of 24. Let's say you did it by the factoring method. You did 12 and 2. You broke this down into 6 and 2. You broke this down into 3 and 2. You pair up any partners you have. One of them gets out. So how many 2's am I going to pull out of this radical? Just one of them, right? Because one of this pair. Okay. So I pull out one of those 2's, which means I'm left with 6 times 2 on the outside because I have the 6 from before and I pulled out one of the 2's. On the inside, I'm left with this 3 and this 2. And whatever's left on the inside just gets remultiplied back together 2, and it becomes a 6. So the final answer would be 12 radical 6 would be the simplified answer to this expression.
Mr. Mill, I got that right. Dead serious.
Good.
100%.
Look at another like that. 4 radical 10 times 3 radical 6. Multiply those expressions and simplify the square root if necessary.
If you're doing this correctly, I'm not positive. Let's see here. 12.
We're knocking this one out of the park.
So when you multiply square roots, you multiply stuff on the outside together. 4 times 3, 12. Stuff on the inside. 10 times 6, 60. So now I have to simplify 12 radical 60, or 12 times the square root of 60. One way I can do it is I can start looking for the largest perfect square that's a factor of 60. I can just start going through my perfect squares. 1, 4, 9, 16, 25. Start going through them. The largest one that goes into 60 is what? I think most people are prime factoring, so let's do it that way then.
I use 10 and 6.
If you break that down into 30 and 2, You break that down into 15 and 2. You break that down into 5 and 3. They're all prime now. I have one set of partners that comes out. So 1, 2 will come out. Remember, one of these gets out, and then whatever's left over stays in. So when the 2 comes out, what's going to be on the outside of my radical then?
2 times 12.
24. 2 times 12, which is 24. Right? Then on the inside of my radical, I still have the 5 and the 3, and I just remultiply those back together. It's not 53. There's still 2 factors. So it's 15. I can't break down 15 anymore. Simplified, so the correct answer would be 24 radical 15. That would be the simplified answer to this. One more like this. 5 radical 4 times 3 radical 4. Simplify that expression. All right, so let's go through this. Multiply what's on the outside together. 5 times 3 is 15. Multiply the inside together. 4 times 4 is 16. Now, I had a lot of people that started breaking down this 16, but you actually already know the square root of 16 because it's a perfect square. It's what? 4, which is 60. Okay? Even if you did it the other way,
Yeah, what if you did 8 and 2?
so if you broke it down into 8 and 2, 4 and 2, 2 and 2, right? So you circle your pairs. 1 pair there, 1 pair there. So 2 2s will come out. You'll be left with 15 times 2 times 2, and there's nothing left in the radical, right? So 15 times 2 times 2 is 60. You don't write the radical when there's nothing left. But don't forget to check at this point. If that's a perfect square, you already know that's a perfect square. Just simplify. It becomes 15 times 4. Yeah. So here, let's simplify square root of 90x to the 4th. Okay. So I want to know, are there 2 like terms that are the same that you can multiply to get 90x to the 4th? Well, 30, that's a good thought, 30x squared, because 30x squared times 30x squared would be 900x to the 4th, though, right? But that's what we're looking for, right? So we know that we can break this up into square root of 90 times square root of x to the 4th. Again, that's just a property of square roots, is that anytime you have something being multiplied under a square root, you can take the square root of each part separately. That's just a property, it's a rule. Okay? And we know how to simplify the square root of 90, right? We can simplify the square root of 90, a bunch of you like the factory method, I think. That's 3 and 3. So a 3 would come out. No, that breaks down into 5 and 2, but again, that doesn't break down at all. So a 10 would be left in, right? This radical 90 breaks down into 3 radical 10, right? Because this breaks down into radical 9 times radical 10. Radical 9 is 3. Square root of 9 is 3. The question is, how do you break down x to the 4th? Well, one way to look at it is you have 4 x's being multiplied, right? That's what x to the 4th means. And the same rule applies for them. If they pair them up, one of each pair gets out of the radical. So that means I have 2 of them getting out of the radical, none of them left over. So the simplified answer would be 3x squared radical 10. Okay. But if you think about it this way, what's the square root of x to the 4th? Meaning what variable to what power times itself gives you x to the 4th? It's x to the 2nd, right? X to the 2nd times x to the 2nd is x to the 4th. So we just pulled that out. Again, we did the same rule, though. We paired up any partners. One of each of the partners got out. Whatever's left over stays in, but there wasn't anything left over. All right? Try this one then. Square root of 40x to the 4th, y to the 5th is e to the 3rd. Simplify that as far as you can. Now remember, one of the rules of square roots is you can break up the multiplication problem separately. So there's 4 different things being multiplied here if you look at it that way. So you could break it up into square root of 40 square root of x to the fourth, square root of y to the fifth, square root of z to the third. So like that, whenever things are being multiplied under the square root, you can break them up separately. Maybe an easier way to look at it. And then just take it one step at a time. You can simplify square root of 40. What's square root of 40 going to simplify to?
82.
Say it again.
22.
If you did 20 and 2, okay, then you broke down 20 into 8 and 5 would work too. But whatever happens, whatever you get, again, you can think of it like this, right? It's going to be 2 radical 10. Right? Everybody agree with that? That's what square root of 40 breaks down into?
Yeah.
Because you have one pair of 2s, one gets out, you're left with 5 times 2 on the inside. So I simplified square root of 40. Again, the other way I could have done it like that. What is the square root of x to the fourth? X is x squared, right? Because there's another way to look at it. There's 4 of those being multiplied. You can pair up 2 different. So x squared. Because x squared times x squared is x to the fourth. There's none of the x's left on the inside. Here, there's 5 y's. So I have one pair there, one pair there. So how many y's get out of the radical? 2. How many y's are in the radical? 1. Because there's this 1, right? I had a pair there, and this one left. And then z to the third, that's 3 z's being multiplied. I have one pair of them, so how many z's get out of the radical? 1. How many z's are in the radical? 1. So that would be my final simplified answer. Now, a couple things to note here. You will never have more than one variable inside the square root, right? Because if there is more than one, you would just pair them up and the one gets out, right? So if you ever find yourself with more than one variable in the square root, you need to simplify further. Because if there was more than one, they'd have a partner to get out. Again, we're just talking about here, what is the square root of like x to the fourth? That's x squared, because x squared times x squared is x to the fourth. But all we're doing is we have a different way to look at it. Also, one way to look at it is you're actually just dividing all these variables by 2, and if there's a remainder, you're leaving it inside. Right? If you divide 4 by 2, you get x to the second. If you divide 5 by 2, it goes in 2 times with 1 remainder. And if you divide 3 by 2, it goes in 1 time with 1 remainder. Just another way to look at it. Questions there? Last problem of the day, and then we'll look at the assignment. Simplify that expression. It's all multiplications. You can break up each of the square roots separately.
Gosh, that was good.
I broke up 50 into a radical 25 radical 2 because I know 25 has a square root. So it simplifies into 5 radical 2. That's what square root of 50 simplifies into.
I heard it wrong.
The factoring method, you had a pair of 5s, circled them up, one of those came out, you were left with the 2. Here with the x's, I have one pair of x's. That's like an x squared. What's the square root of x squared? Well, just x. One of the x's gets out, but I'm left with one on the inside, right? And then with the y's, I have a pair there, a pair there. That's like y to the fourth, and the square root of y to the fourth is y to the second, and you're left with a y there. I can't go any further. That's my simplified radical. Questions with that?